Hello everyone, we are Seki and Kunimitu from Akashi National College of Technology. Today, we are announcing about over-compaction detection system. Over-compaction is an unfamiliar word. What is this word? It is a technical term of civil engineering. When you make a road, it's a problem if the ground is soft. Therefore, force is applied to the ground, asphalt, etc. to push out the air, increase the density of the particles, and strengthen the ground. This is called compaction. However, if you do it too much, the ground will become soft. On the contrary, this is called over-compaction. Civil engineering is large-scale and requires long-term use, so durability and safety are important. Certainly, in the field of civil engineering work that was previously done by humans is being done using ICT. All buildings and roads on land stand on ground after compaction. The ground is the foundation for all land structures. The leveling of the ground will affect the durability of the building. If it becomes over-compacted, the only way to restore it is to dig up the ground, restore it to its original state, and then compact it again. This will cost you money and time. Until now, in order to stop the compaction before it becomes excessively compacted, we have made decisions based on the long experience of professionals. Therefore, this time, we were interested in using ICT to develop more efficiently and stably than before, and focus on the problem of excessive rolling compaction. As a solution to these problems, we wanted to create a system that would give a warning just before over-compacting, so that even a non-professional would be able to do so. If we write a program and build a system, the machine will tell you where to stop compaction even if you don't have the experience of an expert. Here it is. There are 3 major improvements in this system. As an implementation method, 1. Take pictures of the ground after compaction automatically. 2. A characteristic texture appears on the ground just before over-compaction. Image processing is done to enhance it. 3. Machine learning is used to run over-compacted photos and photos just before over-compacted. 4. Alert you when the soil is about to be over-compacted. This is a flowchart. This system has 3 goals. The first is to build an image processing system that can determine excessive rolling compaction. Emphasizes distinctive textures required for image search. It then uses machine learning to determine if it is over-compressed. This time, I tried searching for images using an existing application. The third is to turn these systems into applications so that they can actually be used at construction sites. Due to scheduling conflict, the experiment was not possible. I would like to continue doing this in the future. The content of the experiment is: we used rollers that were actually used in the field to create an over-compaction state on a trial basis. We observed how many times the rolling compaction would produce a characteristic texture and what kind of change there would be. I created a program that emphasizes characteristic textures from photos taken in an experiment. Finally, machine learning was used for judgment. We didn't have time, so we used an existing app, but we would like to create our own image judgment program. Problem: highly accurate machine learning program. Differences in changing rolling compaction trend due to ground conditions. Match the soil type. I think it's a difference in environmental conditions depending on the location, such as the climate and the degree of consolidation of the ground. As a future prospect, I would like to develop an advanced image analysis program that can be used to make judgments under different conditions, such as the type of soil. Also, when it is implemented, we have not been able to confirm the extent to which the camera can be attached and judgment can be made.